Good morning, everyone. Warm welcome to the next session in Java. So in this session, we are going to discuss about polymorphism in Java. As we covered what is method overloading in the previous session, still I will explain briefly about method overloading. And before going to see about method overloading and method overriding, so let us see what is polymorphism, what are the types of polymorphism in Java, and how the types of polymorphism is included in Java. Right? So, in Java, not in Java, in any of the object-oriented programming languages, polymorphism means many form. Polymorphism means many form. So, if a method is defined more than one time, the method is defined more than one time in a program, then we can say it as a polymorph. That is, the same method name is existing more than one form, right? So polymorphism means many forms, right? And one more thing is, it is a Greek language code. It is a Greek language code. There are two things here: method overloading and method overriding. So method overloading is an example for static polymorphism, and method overriding is an example for dynamic polymorphism. So let us see what is method overloading and what is method overriding, right? So remember this point: same class, right? Same method name, right? Same class, same method name, right? But different different parameter profile, right? So same class, same method name with different parameter profile is called method overloading. And at the same time, here we can say different class, right? Different class and same method name. So if we have a Java program, in the Java program, if we have a class, and in the class, if we have more than one method with the same name, and with different parameter profile, then we can say it as an coupled and polymorphism. And then if we have same method name in different classes, if we have same method name in different classes of the same program, then it is called as method overriding, right? So what do you mean by parameter profile? Parameter profile in the sense it includes, right? It includes number of parameters. Next one, type of parameter, and third one, order of parameters, right? So parameter profile includes number, type, and order of parameters. So here what we have in the sense, we have taken different parameter profiles. That means while we are overloading a method, we should have difference in terms of number of parameters, right? Or we can have difference in terms of order of parameters, or we can have difference in terms of type of parameters. So we have to show any one difference either in terms of type, order, or number of parameters in case of method overloading. Right. So let us see an example program on method overloading. Right. So let us have a class m, right? And inside m, right, inside m, let us consider a method called as void, something called as void csv, right? And what this method will do is it will print something on the output. For example, it will print computer science and engineering. What it will do is it will also print civil engineering. It will print civil engineering over the output. So here there is no problem with all these things because all the three methods are defined with a separate method name. For example, I have another class, right, MO, the class name is MO, and inside this class I am defining the main method of Java. Right? So inside this MO, our class name is M. So let us create an object M space obj equal to new M, right? New M, and now an object is created for the above method, and with this object, I can access CSC. With this object, I can access ECE, and with the object, I can access civil engineering, that is CE method. So let us save the code, and here the main method is located in MO. That's why I need to save the program with mo.java, right? mo.java. Let us compile this one first, so there are no errors. And now run this one. If I run this one, if you observe, it has printed computer science and engineering, and electronics and communication engineering, and civil engineering. So this is what we generally do, right? This is what we generally do. Now let us convert this program into method overloading. So here there are three methods in the class M, right? So if we want to convert this program into method overloading, we need to have same class. So M is the same class here. The first condition is satisfied, and the second condition is same method name. So here if you observe, the method names are CSC, EC, and CE. For example, if I change all these method names to CSC, if I change all these method names to CSC, then the second condition is also satisfied. So the first condition is we should be in the same class. So all these three methods are in the class M, and the second condition is the method name should be same. This is what we have seen here, the method name, same method name. And the third one is there is some difference in terms of parameter profiles. There we have to show some difference in terms of parameters. That is, we have to maintain the difference in terms of number of parameters. We have to maintain the difference in terms of type of parameters, and we have to maintain the difference in terms of order of parameters. At least any one we need to maintain in the program in order to achieve method overloading. If you observe all these three methods, this method has 0 parameters, this method has 0 parameters, this method has 0 parameters. So there is no difference in terms of number, type, and order. Right? So here, if you maintain, for example, there is one parameter called as int a, let int a float b, right? Int a and float b, and if this method will execute by passing a single parameter, and if this method executes by passing 0 parameters. So if you observe the program, this method will execute when no parameters is passed. This method will execute when one integer parameter is passed, and this method will execute when two parameters, one is integer and one second one is float parameter is passed. So we need to make a little bit changes in the code. So all the three method names are CSC, right? All the three method names are CSC. So if you want to execute first method, right? We need to pass two things. If you want to execute the first method, we need to pass integer value followed by float value. So here, pass an integer value, right? Pass an integer value and pass a float value. Right, pass a float value, and then if we want to execute the second method, it is having only one integer parameter. So pass one integer value, any integer value, and to execute the third method, there is no need of parameters. So now, now we have maintained the same class. The method name is same in all the method name is same in the class, and there is some difference in terms of number of parameters. This method consists of 0 parameters, this method consists of one integer parameter, and this method consists of 2 parameters. So there is difference in terms of number of parameters. Now, if I compile and execute the code, right? I compile and execute the code, it is printing computer science, electronics, and civil engineering, right? So now let us see how we can show the difference in terms of type of parameters. Here, if you observe, we have shown the difference in terms of number of parameters. Now let us make the number of parameters common, right? Let us make number of parameters common, right? So if you observe here, if you observe in all the three methods, here there is one parameter, here there is another one parameter, and here also there is one parameter. So there is no difference in terms of number of parameters. Now what we have to do is, we have to show the difference in terms of type of parameters, or we have to show the difference in terms of order of parameters. So here we are dealing with only one parameter, that's why we cannot change the order. So at least we have to show the difference in terms of type of parameters. So here the first parameter is a float point type, second parameter is of integer, and third parameter is of character. So first one we have to pass a float value. Now to execute the first one we have to pass a float value. Second one we have to pass an integer value. And now to execute the third one we need to pass a character, any character. Right? So compile the code and then run the code. So if you observe, it is printing the output perfectly. So this is how we can make the changes in terms of type of parameters. And now let us consider one more thing. Int a, sorry, int something called as a, float b, char c, right? Int a, float b, char c. Here what I am doing is I am maintaining number of parameters and type of parameters common, right? Number of parameters and type of parameters common, and I am changing the order of parameters here, right? So here three method names are in the same method, same class M. Here the three method names are CSC, CSC, and CSC. So here if you observe, there are three parameters, right? The three parameters are int, float, and char. And here also there are three parameters. Three parameters are int, float, and char, sorry, and character. And here also you can find three parameters, int, float, and char. So in all the three methods, there is no difference in terms of number of parameters. There is no difference in terms of type of parameters. All the three methods contain integer parameter, character parameter, floating point parameter. But main difference in all the three methods is that there is some difference in terms of order of parameters. Right? If you observe the first method, we have integer first, float next, and character third. Int, float, char. And here, char, int, float. So the order has been changed. Here, int, character, float. So if we want to execute the first method, we need to pass an integer value followed by float value followed by a character, right? And if we want to execute the second method, first we need to pass something called as one float value and then integer value and then character value. I'm sorry, just a second. If I want to execute the second method, I need to pass the character first. Then I need to pass the character first. Just a second. Character first, followed by integer. So here I need to maintain an integer value, it's not a float value. Integer value and then float value, right? And in order to execute the third one, I need to pass an integer followed by character followed by something called as float value, right? Save the code, compile the code, and you find no errors, and now run the code. If I run the code, it is printing the respected statements inside the methods. So this is how we can do the method overloading, right? So let us revise this one once again. It is a Greek language word. Polymorphism is a Greek language word. Remember, this is very, very important, right? This polymorphism concept is very important in any of the object-oriented programming languages, right? So it is a Greek language word. It is a combination of two words, poly and morphism, where the poly means many and morphism means forms, right? So it is of two types. Polymorphism is of two types: static polymorphism and dynamic polymorphism, where the other name for static polymorphism is compiled-time polymorphism, and the other name for dynamic polymorphism is runtime polymorphism. So the example for static polymorphism is method overloading, and the example for dynamic polymorphism is method overriding. So the method overloading can be defined as we have the same method name in the same class with different parameter profile, then it is called as method overloading. And in case of method overriding, if we have same method name in different classes of the same program, then it is called as method overriding. So how we can show the difference in terms of parameter profile in the sense, we can have difference in terms of type of parameters, number of parameters, or order of parameters, right? So let us have a look at the concept of method overriding. So as we mentioned that method overriding, when we have same method name inside two different classes, the same program, and those two different classes should be in inheritance relation, and the two different classes should be in inheritance relation, right? Now let us move to the one. Let us move to the code. Just a second. Let us move to the code. Right? Let us consider one more Java program. Right? Here, let us start writing method overriding. Let us rename this one as MB. Right? Now, keep the main class aside. Keep the main class aside. I will discuss about later this one. So let us see what is method overriding here first one. Right? So here in this class, and the class name is something called as A, and in this class I have a method called as M, and what this method will do is it will print something called as hi, right? And I have one more class. Here my class name is B, and in this B I have a method called as m, and this method will print good morning, good morning. So there are two methods. Both the methods are of same name. These two methods are located in two different classes. So here if you observe method overriding, there should be different classes and same method name, right? Different classes and same method name. If you observe, these are two different classes. This is class A, it belongs to class B. But the method name is same. And one more point we have discussed here, they should be in inheritance relation. So let us use extends A. So now A will become the parent class and B will become the child class. That means A and B are in inheritance relation. And both the things are in inheritance relation. And if we have two methods which are of same name in both the classes, right? And we have a method the same name in both the classes, then the concept is called as method overriding. Right? Now let us bring this main method. Let us bring the main method. Right? So here class MB, right? Inside MB, what I'm going to do is, right? What I'm going to do is, I want to create an object for class A. For example, A space obj equal to new A, and I want to create an object for class B also, right? B space obj1 equal to new B, right? So I have created objects for both the class A and class B. So let us solve the methods obj dot m, obj1 dot m, right? obj.m and obj1.m. So let us save the code as mv.java. Compile the code first. I think we have missed some semicolon here. Save again. Compile the code again. So there are no errors. Now run the code. Run the code. It has printed hi and good morning. Right? So both the times, if you observe both the times, we called the method m only. But the first method has printed hi and the second method m has printed good morning. How this is possible in the sense, the first method is executing obj. Obj means class A's m method. Second method is executing obj1. Obj1 means class B's m method. So class A m method will print hi, class B m method will print good morning. Right? So that's why we got hi and good morning as an output of this code. So this is the concept of method overriding, right? So if we have two methods with the same name, so both the methods are with the same name m, and with the two methods are situated in two different classes, and if the classes are in inheritance relation, then the concept is called as method overriding, right? So it is also called as runtime polymorphism. And one more thing, we have discussed about super keyword, right? We have discussed about super keyword. For example, I don't have any object for class A. I don't have any object for class A. I have only an object for this one, class B. And with this B object, I need to execute both the methods. If I want to execute both the methods, I can use the thing called as super dot m, right? Super dot m. Save the code, compile the code, and then run the code. If I run the code, still it is printing hi and good morning. If you observe, I have only just called the m method which was under object 1, obj1. Obj1 means class B. Class B's m method only I have executed. So this method will start executing. In this method we found that super.m. Super.m means the m method which was located in the super class. So the super class for class B is class A is the super class for class B. So it will execute, the control will execute the method m which was present in class A. And if the method m was executed, it will print hi. And after the execution of method m, it will print the remaining lines of method m which was present in class B. So the remaining lines in method m will print good morning on the output screen. So hi and good morning will be the output of this code. Now I think everyone is clear about this one, method overriding and method overloading, right? So in the next class, we are going to discuss about the concept called as abstract classes. We will discuss about abstract classes in the next class, right? So after the completion of abstract classes, we go for interfaces and we go for packages, right? So the discussion of abstract classes, it will take us to one or two classes, and interfaces will consider up to one or two classes, and packages will take one or two classes. So maximum in a 1 week, we are going to complete the second unit also, right? So please practice the programs once again, right? Please practice. And if you have any queries regarding today's session, you can make a comment in the comment box. And in the next session, we will meet the topic with the abstract classes. And I thank each and every listener of this video for being here, and hope you all got some knowledge regarding polymorphism in Java. And we will meet you in the next session with abstract classes. Thank you once again.